There's a molecule of atmosphere. There's unpolarized light. So I'll show again. Only diagram is there, formulas are not there. Please do note. I think I entered this in formula book. Some important data is what I'm going to write. That is very important. That is not there in the most in any of the book. Possibility of asking. So there's unpolarized light. So there's a sunlight, unpolarized sunlight. What are the sources of unpolarized? I'll switch on the tube light. Is it a polarized or unpolarized? Anybody? It's unpolarized. Sun. Then also the oil wick lamp, candle, Bunsen burner. All these are unpolarized light here. Okay, got this. So there's unpolarized light. So the light, what happens? Sunlight, what happens when it's incident on a molecule? So what will happen is like the, the human eye will be here. Okay, there's a human eye. What you see that you will see the linearly polarized light. The human eye, what he notices that he will notice that linearly polarized light here. That is what will be seen by him. Polarized light, what happen will be visible for him. And that polarized light, what happen will be oriented normal, will be scattered. So it's not say, don't say reflection, scattered polarized light. And it will be linearly polarized here. Scattered polarized light will say. Then what happened? Some light will be scattered where it will be partially polarized. There is no sequence. You can see that the way I'm putting no. So partially polarized here. Then unpolarized light will propagate in this direction. Okay, this arrows here. No. So the light which is not scattered, unpolarized light. No scattering. A light which is scattered by 90 degrees will get polarized. So what is the polarization? So you can put it like this. This will be the red dots. Will put it. Okay, so linearly there's unpolarized light nearby. This will light it linearly polarized. This will be partially polarized. This is again unpolarized light. So the scattering angle, this is theta. So let's discuss about the intensity of unpolarized light. Let it be I. The one which is not scattered and which is unpolarized, no. So its intensity will remain I. The one which is according to this one, this will be I by 2, the intensity. One which is scattered by 90 degrees. The one which is scattered by the angle theta, it's given, it's the formula is given by I by 2 by I by 2 cos square theta. I think I don't know why in books it is missing. but something very important. So let's put this formula, put theta 0, intensity of unscattered light. What is intensity of linearly polarized light? Put theta 90. Simplest thing. In NCERT book also, we don't have any discussion on this, but in exam, they may ask you. So what is IP this one? Intensity of light. Intensity of light scattered by an angle theta and which is partially polarized. And what will happen to the light which is scattered by 90 degrees? It will be linearly polarized. The light is linearly polarized. Unpolarized incident sunlight. The molecule. So like that, what happen? What we see is this particular thing. If this light enters, okay, we see that intensity variation. Okay, just I think there's a information what you must remember. Anyway, they can mix with this ray optics, Bravestius angle, critical angle. Some questions will come. Please do think on them. I'll show one photograph. What is the use of this polarization? Just I'll get it. It's here. This is very important. Last, like what is the use of polarization? What Leffen will come to know. Let me bring that photograph here. Yeah. Oh. Just wait, it got stuck somewhere. I'll just show that photograph. Okay, I'm able to get it. You're able to see the screen? Okay, fine, yeah. Can I continue? I thought time may not be sufficient. I wanted to show. Okay, now we have. And I'll put the data. Those who are interested, you can read that. This is something photography. If you don't know polarization, I think you should not become photographer. That's what I mean to say. Okay, let's get into the. All of you are able to see the two photographs. See, photo, when you take photograph, no, you can see the, especially some movies, no, especially some Western movies, the way things will appear so beautiful. It's all about, the polarizing. So when you purchase some camera, when you purchase a camera, on the front, what happen, they'll keep the some polarizers. That polarizers, what happen, will make things very beautiful. What is the reason for that? Because we know the light, when it passes through atmosphere, it will get reflected, scattered. Some light will be scattered. So what will do, this lens open will capture that even the extra light that was got scattered, and it will make that enter. Because of more light entering into the lens, the intensity of that will increase, and it will make the sky appear to be like this. I think definitely, which one you like it, I definitely say the right one. You see how ugly it looks here, ground, everything. Not that, but here it appears more greener. That's why you look at uh, the Discovery Channel, the National Geographic Channel. You look at this one, and TLC, some Good Times, NDTV Good Times. So like that, we have so many channels, no, which will they show more about the Western countries. And the photographer you see at the end of the program, no, it'll be the Western one. And if you actually go and what they show and check that on YouTube or in the internet, no, the scenery will not appear like that. What it should to be, practically it will be like this. But using photography, using the polarites which is fixed in nearby the in front of the lens, the video camera, no, that will make that particular appearance to be like this will appear more beautiful. So one good example, latest you can see, India Australia test series. Why things so clear? The same test match occurs in India. Why there's no clarity? That's what the reason. The equipment what they use. You look at the Western movies, no. So many Western movies are there. You look at that and look at our Indian movies. Why the beautification of the image is not there? Means the use of polarizer. It's not that. See, we can purchase polarizers, but you should know how to use polarizers. You have to rotate. The rotation will make such that it will appear beautiful, because the pass axis is very important, because the scattered light will be partially polarized. This will help us to beautify the image. If you can make this light also to enter, say this is what we see. You have to gather this also. When this light is made to enter into the lens using polarites, then what happen? And that too you have to orient, no, because you see the partially polarized. So for that, what happen? The beautification of image will take place here, and this is what happens here. I think this what like a, if you look at the things, no, the swimming pool which is a normal color, it will appear bluish, no. The reason for that, there is one. So if you look at the some oceans which are green in color, they'll make them to be appear blue. How do it all depends on polarites. So what all today photograph, you must know the polarization. Means the lens, polarizing lens, they're costly a little bit, 5,000, 6,000 you have to purchase, and you should know how to use. That will come by only practice, the different orientation, because you don't know in that particular position how the direction of scattered light. So you have to experiment. That's why the Western movies, they take more time, 2 3 years. The only reason for that, the beautification. In India, within 3 4 months, when we want to wind up movie and we'll want to go for next movie, there's a thing. There's a difference will come. The use of technology is something very important. So I think if you go for Canon, no, Canon cameras, Nikon, they do sell the polarizing lens also. So purchase any one if you have a camera, no, then you see the way